So welcome to our 8th session in our series on life's big questions. And we start with the question then, has science disproved the Bible? And this is the main thing that we're going to be talking about today, and particularly as this question relates to the theory of evolution. And I think the answer to this question is very straightforward. A very simple answer, no. And I could then stop straight away, but I hope that you want me to keep going to tell you why I think the Bible has not been disproved by science. So let's start by thinking about the Bible. The Bible has been a trusted book for many, many generations, but at the moment, for many, trust in the Bible has been diminished. And why? Well, there are probably two reasons, really. The first being that the people who should be defending it, for example, theologians, they can often be heard publicly undermining the Bible's authority. And secondly, it's a commonly but mistaken belief that science has actually disproved the teaching of the Bible. So we'll look at these things now. It's really important to note that the vast majority of the great scientists of the past were believers in God, and some of them, like Sir Isaac Newton, were also accomplished Bible students. But belief in the Bible is not just limited to scientists in the past. There are many eminent scientists today who are believers in God and the Bible. These include both current and past Fellows of the Royal Society, as well as a number of Nobel Prize winners. In 1997, a survey was carried out by the science journal Nature, and they found that 40% of all scientists in America believe in God. So, many scientists themselves believe in God, and their job does not stop them from believing. Let's look at a few quotes from some past Nobel Prize winners who were believers. So, Sir Ernest Chain, he said, "To postulate that the development and survival of the fittest is entirely a consequence of chance mutations seems to me a hypothesis based on no evidence and irreconcilable with the facts." He was famous for his work on antibiotics. Now let's look at another one. Dennis Gabor, winner of the 1971 Nobel Prize in Physics. "I just cannot believe that everything developed by random mutations." Now, in some places that quote is actually given as, "I cannot believe that anything developed by random mutations." I think this is probably the correct quote. And thirdly, Richard Smalley, who is famous for his work with so-called buckyballs, Buckminster fullerenes, an allotrope of carbon. He said, "The burden of proof is on those who don't believe that Genesis was right, don't believe there was a creation, or that the Creator is still involved." The late scientist Stephen Jay Gould, he was a famous paleontologist. He was also an evolutionist, and he was a science historian as well. And he said, "Unless at least half my colleagues are dunces, there can be, on the most raw and empirical grounds, no conflict between science and religion." In other words, he was saying that science and religion were, in the mind of many of his colleagues, not incompatible. And we'll say now several times that the Bible is not a science textbook. It deals with questions more like why we are here and why things were created, and not so much with the how that science tends to concentrate on. Many believing scientists will say that their job actually helps them to look into how things work and strengthens their faith in God. Now, having said that though, millions believe that science has irrefutably proved two things. The first being that the universe started with a big bang, and secondly, that life came about by a process of evolution. Now, if these beliefs were true, it would follow that the Bible must be wrong in talking about our world being created. But are these assumptions true? What we suggest is that we need to think about this a little more. We'll see that it's important to distinguish between facts and hypotheses or theories. If we deal with just the facts, we will see that both the Bible and science suggest that the universe had a beginning. The facts also show that life appeared in complete forms. And overall, we'll see that there is no conflict between scientific facts and what the Bible says. Now, we'll look at facts and theories in science. We'll look at the facts about the origin of the universe. We'll look at the facts about the fossil record. And we'll look at what some scientists themselves say about evolution. So firstly, facts and opinions as they relate to science. Science has to work with facts, and they need to use them to develop theories. Some examples. A faraway nebula. We have a picture there of one. A rock formation. It's a fact, just like that faraway nebula which you observe through a telescope. What you are seeing is a fact. A rock formation is a fact, and a fossil that you might find in that rock formation is likewise a fact. So facts, they are things that can be observed. They're things that can be proved beyond doubt. They're tangible. They're measurable. And they're repeatable. Facts can be experienced through our senses and felt firsthand. These are things that we can experience. One fact that we're well aware of is gravity. We all experience gravity, don't we? If we drop something, it will fall. Always. Every time. Now, scientific experiments have been carried out to investigate gravity. It's now so well understood that rockets have been launched into space. It's common for satellites to be put into orbit. Gravity is real. It can be measured. It can be experienced. So gravity is an observable scientific fact. Let's now look at some other things. How a theory is generally developed. It's an important point. Science is based on available facts, observations. And scientists make observations. Now, scientists will develop an idea that might explain some of the facts. And in doing that, they have to test the idea, and they think up experiments, as many experiments as they can, to try to predict from the idea what the outcome of those experiments should be. And if what is predicted happens often enough in different experiments, then the idea can become a theory. But if not all the results confirm the idea, then it gets modified and adapted until it does predict correctly what happens in all the experiments that a scientist can think of, or several scientists might think of. So the more tests that are performed satisfactorily, the more confidence that scientists can have in their theory. So they test assumptions. and proven assumptions then become a theory, and confidence is gained through testing. So we see the important point that a theory must have extensive testing if we're going to be able to have confidence in it. Now we've seen that a theory then can only be used and trusted in real life when it's been tested and tried. I'm an engineer, and engineers can only use theories that are actually tested, that can be relied on. For example, when you might build a bridge or something else like that. We have to accept the tested theories. For example, strength of materials and things like that. We can only work with things that we know are facts, that can be checked and tested. And we'll only put our trust in theories that have been tested. Now, sometimes when theories are proposed, there is no way of knowing that the assumptions that are used to form the theory are right. It's often the case, for example, in things in the distant past. In such cases, we can't carry out experiments to prove that the assumptions are correct. So it's important to know what can be proved and what is just a theory that can't be proved. In the past, there have been many theories which were based on assumptions which were later found to be incorrect. Let's have a look at a couple of those. In the mid-19th century in England, some public health authorities believed in the miasma theory. The theory said that diseases were caused by a poisonous vapour known as miasma. And in the same era still, some doctors accepted the dyscrasia theory, which said that disease was caused by an imbalance in bodily fluids or humours, phlegm, blood, yellow and black bile, and so on. And people did their best with their limited knowledge, but they were unaware that they lacked vital information about viruses, bacteria, and many other things, some of which we know and understand now. And what were the consequences? Well, they saw no problem in drinking water being contaminated with sewage, and the result was the deaths of tens of thousands of people in the 4 cholera epidemics that broke out in England between 1831 and 1854. And they didn't see a problem in having a doctor or a nurse working on a dead body and then moving to examine a living one without washing their hands in between. So up to 1 in 3 women giving birth to children in hospital died. Many women preferred to give birth in the street rather than go to hospital. Countless people died because these theories lacked vital facts. These 2 examples show that we do need all the facts to come up with a correct theory. They also show us that we may not realise when we don't have all the facts. So, Newton's laws we hear about, and they were later tweaked when Einstein began to understand relativity. As we gradually learn more, we can often realise that what we knew in the past was inadequate. And this is true still about many theories. So let's have a look at what the observable facts are that make up the Big Bang theory. When people use modern telescopes to look at distant galaxies, they find that the light looks slightly different from sunlight. The simplest way to describe the difference is to say that the light from distant galaxies looks slightly red, and this observation is known as the redshift. When people look at through modern telescopes at distant galaxies, they, yes, see this redshift, but we also, if we look using telescopes that are in space, we can detect radiation that is known as cosmic microwave background radiation. And it needs to have some explanation. What is it that creates that radiation there? Another fact, the universe involves elements that change in their weight, if you like, in their size. So things like hydrogen, helium, oxygen, nitrogen, carbon, and so on. And scientists have noticed that the universe contains mainly elements that are very light in weight. So the lightest two elements, hydrogen and helium, are by far the most common elements in the detectable universe. And the fourth fact, that galaxies seem to be evenly spread through space. It doesn't matter what direction we look in, the spread of galaxies seems to look basically the same. So these are the four observable facts on which the Big Bang theory is based. Now, observation is what sparked the theory about the Big Bang. And this observable fact, the redshift, was the one that originally made scientists develop the Big Bang theory. Scientists believe that the redshift in light coming from space indicates that the light source is moving away from us quickly. And that would mean that the universe is expanding, that we're somewhere in the middle of it, not necessarily the very middle of it, but that there is a lot of the universe expanding away from us in all directions. That was an observation that was made. And the other observable facts that we've looked at are also consistent with the idea that the universe started with an explosion and expands then in all directions, just the way we see things expand in an explosion. And the background radiation is said to be then the remnants, the remains of the Big Bang. And the Big Bang suggests, as a theory, that the lightest elements would be produced first, and that heavier elements would be built up from them in processes in stars. And scientists also realised that the galaxies would be evenly distributed through space if the universe were expanding in all directions after a Big Bang. So these observations fitted then with a theory which they gradually developed. But to come up with these ideas, this theory, they've needed to make assumptions. So let's look at what the assumptions are. The assumption made first is that the physical laws that we see today are exactly the same as they were at the start, or just after the start. And that these laws are also consistent, that they are the same throughout the entire universe. There is also the assumption that the redshift that we see is caused by having the light source moving away from us, and that the faster the light source is moving away from us, the more redshift will occur. So using these three assumptions together with our four observable facts, it becomes obvious that if our universe is expanding, then if we rolled back time, everything could be traced back to a single point in space from which everything started. And that event is what is called the Big Bang. So, we can remember that this theory is based on what we can see today. Of course, nobody knows what information modern telescopes would show if they had been able to be used thousands or millions of years ago. We just don't know. We also have to remember that we can't do any experiments to prove that the redshift is caused by these light sources moving away from us. What we can see is that, contrary to the impression that you'll often get, there are not very many facts that support the Big Bang theory. It is based on a few fairly simple ideas, and those fit together. They support the theory as long as we accept the assumptions. And unfortunately, they are assumptions that we cannot prove. So scientists are doing their best with the available information. However, the Big Bang has to remain still an interesting theory. But we can't regard it as fact. So let's go on then to think about the theory of evolution, which progresses from the Big Bang. The theory of evolution. Can we be as confident in the theory of evolution as the designers of bridges or other things designed by engineers are in the theories of the strength of materials, in gravity, in stress, and various things to do with electronics? Once again, I think that the answer is simple: no. Well, what tests can we do to assure ourselves about the ideas of evolution? The fossil record is one of the main sources for the facts on which the theory of evolution is based. And going back to what we saw about the scientific method of establishing theories, we could say that the theory of evolution should be the best possible explanation of the observed facts in the fossil record. Or else we should look for another theory. And that then raises the question, well, is the theory of evolution the best explanation of the observed facts? According to Darwin's theory, the species would have started simple and got more complicated. So all living things are classified into species, and then they're grouped into bigger and bigger groups or families. And then the families are eventually grouped into a large, in fact enormous groups called phyla. For example, one phyla is chordates, animals which have a backbone. And according to Darwin's theory, the number of animal phyla should gradually increase with time. What does the fossil record suggest? If we can accept the analysis of the geological record, it shows that for the first 3 billion years or so of the Earth's history, there were basically no animal phyla. Then there was a sudden explosion of the number of phyla, and since the explosion, there has actually been a reduction in the number of different phyla. Interestingly then, the theory doesn't fit with the observed facts in the fossil record. Instead of animal phyla appearing gradually, they all appeared almost instantaneously in the fossil record in a surprisingly short period of time. So the theory does not fit the observed facts. Let's go on and look at the fossil record then. If we assume that life has evolved continuously, we would expect that the facts would show a continuous progression through all those stages. We would expect to find fossils of many plants and animals part way between different species. What are the facts? Well, all fossils are very well-defined types of animals or other things. There are no intermediate fossils. There is no continuous spread of different types of animals. There is no continual growth of new sorts of organs or anything like that, which one might expect. No fossils have been found that can be considered transitional or part-way between the different major groups. But occasionally then we'll have the question, but what about Archaeopteryx? Or maybe an occasional other one as well. Well, let's look at Archaeopteryx. It's a fossil that appears to have feathers like a bird, but it appears to also have a toothed jaw like a reptile. But still, the fact is that all the features of Archaeopteryx are fully formed, and clearly so. It doesn't have half feathers, it has fully formed feathers, just like those on the wings of the birds that we see flying outside today. As far as we can tell from the fossil record, it suggests that everything needed for flight was present in this fossil. It also had a brain case very similar to a modern bird. Basically, from the facts that we have, it had everything that was needed to make a fully formed bird. It's not a missing link for the origin of birds. Now, the lack of transitional forms was acknowledged by Darwin himself a long time ago. He was honest enough to admit the reality of the missing links, and he hoped that in time the gaps would be filled. Let's read what he said. As by this theory innumerable transitional forms must have existed, why do we not find them embedded in the crust of the earth? Why is all nature not in confusion instead of being, as we see them, well-defined species? The explanation lies, however, in the extreme imperfection of the geological record. So that's what Charles Darwin said. But let's look at what people say now. These are more recent quotations. We'll start with one from 1960. Still not very recent, but it's more recent than Charles Darwin. And this comment: there is no need to apologise any longer for the poverty of the fossil record. In some ways it has become almost unmanageably rich, and discovery is outpacing integration. The fossil record, nevertheless, continues to be composed mostly of gaps. So what we see in the fossil record is not a continuous flow from one type of animal to another, but instead distinct, clearly defined animals. Another couple of comments. The extreme rarity of transitional forms in the fossil record is the trade secret of paleontology. And that's again quoting from Stephen Jay Gould. And another one. The fossil material is now so complete that the lack of transitional series cannot be explained by the scarcity of the material. The deficiencies are real, they will never be filled. Now, these were people who believe in evolution, though they often believed in some interesting variations on evolution as well. And that is why they were making comments about these sorts of things. They did not consider that the ordinary explanations of evolution fitted. The lack of transitional fossils was acknowledged by Professor Steve Jones of University College. He published an updated version of Darwin's Origin of Species in 1999, and this is what he wrote. The fossil record, in defiance of Darwin's whole idea of gradual change, often makes great leaps from one form to the next. Far from the display of intermediates to be expected from slow advancement through natural selection, many species appear without warning, persist in fixed form and disappear, leaving no descendants. Geology assuredly does not reveal any finely graduated organic chain, and this is the most obvious and gravest objection which can be urged against the theory of evolution. So it would seem that the basic facts which we should expect to find when considering the theory of evolution are not there. Remember, a theory has to fit with the observed facts, and it has to be the best, often the simplest, explanation that does fit the facts. Cars work. So we know that burning petrol works and that we can get energy from burning petrol. We know that wireless transmissions work, which is why we can do what we're doing now. We know that iPhones work, and so on. These are facts that we can demonstrate and prove. Yet the fossil record does not support what the theory of evolution would predict. Now, this should make us careful in accepting the theory with the same confidence that we attach to scientific laws. Fossils are another example of where the ground rules have been changed during my lifetime. When I was young, fossils were simply defined as the remains of animals or other living things where the original material had been replaced with minerals, if you like, meat replaced with stone. The dictionary definitions I look at still match this definition pretty well. But 3 years ago, I was skimming the Wikipedia page on fossils, just to keep up to date, and that day's version of the page proudly announced to me that a fossil was simply the remains of an animal or living thing that was more than 10,000 years old. So a frozen mammoth, newly dug up from the permafrost, fresh enough to eat if you had the stomach for it, is called a fossil. It's hard to argue against something where the terminology, the language, the meaning just keeps changing. Now, another argument used to support the theory of evolution is the comparative study of modern animals. It's known as cladistics. When you look at animals, you'll see that certain animals look like other animals. And scientists have produced a classification system so that living things that look like each other are classified as being similar. For example, monkeys and humans both have arms and legs, 5 fingers, 5 toes, and therefore humans and monkeys are classified together. As another example, horses and donkeys and zebras all look like each other too, with minor variations. Scientists have looked in this way at all the creatures around the world and classified them all. However, we can't do any experiments that can show they are really related. After all, related in what way? There is no way of knowing how these observable facts came to be. The theory of evolution simply provides one possible explanation of how animals came to look the way they do. A perfectly valid alternative explanation is that some intelligent power created them like that. Another argument that is used to support evolution is variation within species. When I was young, the term evolution was only used to refer to major changes in animals, although sometimes the expression microevolution was used. Now the term evolution is applied to all sorts of changes, large, small, and anywhere in between, and it often seems to include the sorts of variations that we're about to look at. This allows the word evolution to be used for almost any variation or change, which makes it rather hard to deal properly with the subject. When we look at dogs, we see different breeds of dogs. Human beings can interbreed dogs to produce very different dogs in a relatively small timescale. The evolutionary argument is that, given enough time, these variations could, even would, produce new species. However, dogs are still dogs. Despite our efforts, we are not coming up with new species. The different breeds are in fact the result of unnatural selection. They're the result of human interference. So the observable facts are that there are small variations within the same species. However, the simple fact is that the formation of new species has never been observed, and the scale of change observed is vastly different from what is argued as necessary for evolution. It's one thing, as Darwin did, to see finches with different types of beak. It's a huge jump to say that the same mechanism of variation could explain the appearance of a heart for the first time, the appearance of bone, the appearance of feathers, or the appearance of warm-blooded creatures, and a backbone, or anything else. Big changes have never been observed, although sometimes the variations in dogs might seem to be big between, say, a terrier and a Great Dane, but they are still dogs. And it's not good scientific practice to extend known information far beyond what has been seen. It's called extrapolation. I remember being warned about it in Year 10 science and maths. It's just not sensible to use very minor changes as evidence to support the great changes that are required by the theory of evolution. So then let's summarise what we've seen about the evidence used for evolution. The fossil record contains only fully formed animals. The classification of animals tells us nothing about how they came into existence. Minor changes are not scientific evidence of large changes. Extrapolating from one to the other is just guesswork or wishful thinking. So, has science disproved the Bible? Well, the scientists say that the evidence points to a Big Bang as the beginning of the universe. And about 3,500 years ago it was written in the Bible that the universe did have a beginning. We read in Genesis chapter 1 verse 1, "In the beginning, God created the heavens and the earth." So at least in this, science and the Bible are in agreement. There was a beginning. Now let's read a quote of how science tries to approach this. It's a quote from William Stokes and William Lee in the book Essentials of Earth History. And they say, "The fossil record furnishes irrefutable proof that life on Earth has changed through the ages. Fossils prove not only that life has changed, but also that it has progressed from simplicity to complexity with the passage of time. These are the facts. To those who take an unbiased view of the matter, there is only one conclusion, that all past and present life has descended from simple beings." Okay, so that's what people can say when they are trying to support the idea of evolution. So let's look at the statement carefully. Fossils exist. Yes, that's a fact. Fossils are facts. But when you get to opinion, such as expressed in this particular few paragraphs, the opinion based on the facts is that life has progressed from simplicity to complexity. Fossils, of course, provide no evidence to suggest that progression that is described. As a result, you can say that another equally valid conclusion that could be drawn from the facts is that life was created. Now, the Bible makes very little comment about how the world was created and how our world began, except to say what we read in that first verse of the Bible, "In the beginning, God created the heavens and the earth." That is how the earth came into being. So the Bible tells us that there is a creator. Modern science has discovered something of the remarkable organisation of living things. And of course, this organisation points to a creator, a designer. And in this, though they will not necessarily acknowledge it, science supports the Bible. Next time, we plan to look at some of the discoveries of science which also provide more evidence for a creator. So let's just have a quick summary of what we've seen today. First of all, it is important to distinguish between facts, theories, and opinions. Observable facts have to be differentiated from opinions. Opinions should not be treated as facts. And both the Bible and science suggest that the universe had a beginning. Now, science can only work with the facts of the universe as they are now, what they see around them. So the scientific facts that are used to support evolution could actually be used also to support creation. An equally valid explanation of the facts is that the universe and life in it were created. Evolution is sometimes upheld simply because creation is an unacceptable alternative. And if you look in the notes that will be available, they'll include a couple of quotes along those lines, that one of the reasons to accept evolution, despite its impossibility, is that that is preferable to accepting a creator. The overall conclusion we have to come to is that science and the Bible are not in conflict as long as we consider only scientific facts, not opinions.